Text-based image retrieval is a traditional image retrieval method, which each image is assigned with its own metadata, and user need to search based on what have predefined to retrieve the image. The disadvantage of this method is, first, it is impossible to allocate every image with its own specified keywords manually. Second, images can be accidentally tagged wrongly or not uniquely tagged. Third, only suitable for small amount of image data. CBIR is an image retrieval technique based on low-level characteristics of features of the queried image, which can be global features or local features, and it is very useful in different fields. Hadoop is a free, open-source software Java-based programming framework with high parallelization, scalability, and fault tolerance. It supports for storage and processing of distributed unstructured big data on cluster in a distributed computing environment. In this research paper, we only focus on Hadoop FS and MapReduce. Deep learning is a subfield of machine learning that carry out high-level abstraction activities. Basically, the difference of machine learning and deep learning are: machine learning needs to perform feature extraction manually, and it analyzes and learns from data before making an accurate decision. However, deep learning is more advanced than machine learning, as it can self-structure the algorithm in layer form to use the neural network. Besides, it can solve a never-made complicated function by its own brain without the aid of predefined features using domain knowledge. Most surprisingly, it can predict what is the object displayed on the image precisely.
The problem concerned in this research is, first one is the semantic graph, and then the second one is the high dimensions of image features. Then is the high trade-off between accuracy and computational cost. Then the next one is the costly modification and maintenance free. The last one is the incapable of real-time big data processing. To overcome the problems, the deep learning technique is integrated with Hadoop.
The objective of this research is to design and study the system architecture of CBIR system, to study the process of CBIR system, to survey the performance of CBIR system based on Hadoop integrating deep learning, and lastly to survey how the deep learning method can support the Hadoop-based CBIR system. The motivation of this research is to solve the current shortcomings faced by CBIR system, to provide a better understanding and perception towards the overall concept, structural organizations, flows, and mechanism of the architecture of enhanced CBIR system. And lastly, the proposed system can increase the efficiency, accuracy, and rate of accessing desired images from a variety of image databases.
There are two steps of CBIR technique. First step is feature extraction by algorithms. Feature vector is formed by extracting low-level features from each image in the image database. Then, the feature vector is stored in feature database, which index is used to describe the content of image. During query time, query image will be automatically generated by extracting low-level features of particular image. Second step is feature matching. In this step, distance between the feature vector of query image and database images is measured to retrieve those images just with less distance. The criteria for similarity measurement is normally based on what features being extracted.
Those are the related work of CBIR system. The factors which lead to measure difference of the system from aspect of performance and efficiency of image retrieval are the feature extracted by system and the method, technique, or algorithm the system used for feature extraction and similarity comparison. There are several low-level features can be extracted by system. Technique or algorithms applied for the image feature extraction and matching of CBIR are local tetra pattern, principal component analysis, Gauss invariance, feature transformations, and the speed out reduce features.
The research methodology applied is qualitative oriented. CBIR system could restrain the development and usage of this system in different areas. Thus, a new way is proposed and adopted in CBIR system, which is Hadoop framework integrating deep learning model to improve the system and enhance the image retrieval process. In general, the system can be categorized into three modules: image collection and extraction module, image identification module, and searching module. Architecture of CBIR system is constituted by 5 components: image collection, feature extraction, feature matching or similarity measures, feature learning, and pattern classification or recognition. Hadoop framework responsible for storage module and image feature extraction. Deep learning responsible for all modules except searching module. Details explanation will be go through for each modules and component.
Storage module provides a platform for MapReduce job, and it acts as a database for other modules in CBIR system, which consists of image database, image information database and image feature database.
In the image collection and extraction module, image collection is used to collect images from source and then storing them into image base. All related information of image are retrieved and stored in image info base through load balancing method. For feature extractions, it extracts important feature vector from image to store in feature base, which improves the MapReduce job. MapReduce is a framework of programming language which a programmer can manually customize it by applying parallel and distributed algorithm. It consists of two procedures, which are map procedures that work on filtering and sorting, and then the reduce procedures that summarize output information.
Hadoop distributed file system consists of two local nodes. The first one is name node and the second one is data node. Each file is duplicated and distributed across multiple data nodes to ensure the file still can be recovered if node failure case happen. Under this mechanism, master-slave architecture is implemented. Job tracker and name node is master node and task tracker and data node is the slave node.
During feature extraction, job tracker will instruct the name node to search for the exact locations of target data file in HDFS. Once the location is found, job tracker requests each of task tracker to conduct those data nodes. The sorted and shift will yet and store at data node for temporary. Job tracker will send a reduce request to particular task tracker to generate final key value pairs. Then all result will combine and send back to master node afterward to generate final output.
Image identification module. Convolutional neural network is applied. Compose what the feature it learned from input image through 2D convolutional layers, so it is suited for 2D image processing. Remove the need for manual feature extraction, so no feature are required to be identified for image classifying purpose. It is consists of 3 layers: input layer, hidden layer, and output layer. Feature extraction. Input RGB image is divided into many small pixels. Each pixel will enter the first layer of hidden layer followed by fully connected layers to support image classification. One filtering process is carried out by going through one hidden layer each time. By undergo many times of extraction process, the cognitive capability towards feature of deep learning model will be largely enhanced. Result expected from the system is user can upload one or more images at the same time. Images are extracted in parallel by MapReduce procedure. Processes under image identification module run simultaneously. Images with less distance difference in feature vector compared with query image. The image with the high probability to be identified as the object same as query image will be retrieved back to user. Optimization of CBIR. Reliability and usability of CBIR system has been largely improved. The existence of Hadoop framework also can cope with high dimension issue of image features. The image identification module under deep learning model plays the most important role in upgrading the whole CBIR system. By using Hadoop framework, simulate images can be retrieved from the data storage site and also can find the simulate image only with query image inserted. But with Hadoop integrating deep learning, the object in an image can be classified accurately. You can search image by just key in the object's name and able to self-learning and training from a large collection of data. The conclusion of this research is new approach of CBIR system based on Hadoop integrated deep learning is proposed and discussed from theory and architecture implementation views. An overview of distributed and parallel data processing method for large scale of image also introduced. For future work, more study and efforts will be focused on potential issues of proposed CBIR system.
Created using Powtoon.